So far, we have introduced pathways analysis techniques that can be used to analyze a physical protection system and determine the most vulnerable pathway for the system. These methods are best suited for direct paths taken by the adversary. In these slides, we will cover how to evaluate more complex scenarios. Scenario development is part of the analysis phase of the depot process. With scenario development, we are looking at finding the worst case for the effectiveness of the physical protection system. This path will be the worst case interruption scenario, neutralization scenario, or a combination of both these scenarios. A scenario is a detailed plan that describes how an adversary will achieve their goal. They contain realistic attempts by the adversary along the most vulnerable path or paths with conservative probabilities of interruption or neutralization. The analyst must also consider pathways that are highly sensitive to a single detector or single delay barrier. For example, if a pathway has one set of detectors with a detection probability of 95%, what happens if an insider tampers with or disables the detectors? Scenarios include tasks, defeat techniques, and equipment that describe an attack. Unlike direct pathways analysis techniques, they can include collusion with insiders and indirect attacks. Many times, these scenarios are developed using expert opinion. This slide shows an example of a scenario that is crucial to consider and isn't captured by direct path analysis. The security design has a high system effectiveness value for all pathways into the facility. However, the building that houses both the central alarm station and the guard barracks is located on the perimeter of the facility. What happens if an adversary uses explosives to severely damage the building? The facility needs to test their guard force capabilities to ensure a direct attack on the barracks doesn't leave them vulnerable. When creating scenarios, they must have three characteristics. The first is that they are conservative. This means they use the maximum capabilities allowed by the design basis threat and use conservative performance for physical protection system elements. For example, if a detector has a high detection probability for almost all defeat techniques except for a couple, and the design basis threat says the adversary has the ability to exploit these weaknesses, then the security design must use the lower detection probability when describing that detector to test this scenario. Secondly, scenarios must be credible. Credibility means that the scenario is within the capabilities of the design basis threat. It also means that the adversary is giving a realistic success probability for multiple complex tasks. Typically, the simpler the scenarios to carry out, the more credible it is. Finally, scenarios must be consistent. Consistency means that the strategy and equipment employed by the adversary are consistent. For example, it doesn't make sense for the adversaries to ambush the response force and then try to avoid detection through stealth. Also, if an adversary is breaching a wall with a significant amount of explosives, the sound created should be considered with the probability of detection in addition to any sensors that are installed. The impact of insiders must also be considered. This can be done by analyzing the security system and determining the locations where employees could assist the adversary along their path. This can include tampering with alarms, affecting delay barriers, or providing a diversion to the response force. In addition, employees can be evaluated based on the potential impact they could have as an insider. This can be done by systematically looking at all employees at the facility and determining who has access to detector systems or keys to doors or safes. It can also look at who has knowledge of procedures and systems. Facilities will typically try to limit how much employees know to what they must know for their job assignment, so there will likely be very few employees who have knowledge of all or even most of the details of the physical protection system at the facility. Another thing that must be considered when analyzing insiders is who has authority. For example, if there is an alarm, does a senior member of the response force have the ability to tell all the responders to stand down? In summary, the physical security system must be tested against comprehensive and credible scenarios. For direct pathways, we can use pathways analysis and adversary sequence diagrams. For indirect pathways, we must employ expert opinion. These scenarios must be analyzed in a consistent and conservative way to determine the minimum system effectiveness for each scenario. The worst case of all these scenarios will be the effectiveness rating for the entire system, which is then used to determine if the protection system meets the risk acceptance criteria that was defined in the objectives.